Okay, so our next finalist is Augustine Saiz from UC Davis Health, and he will be presenting on muscle secretome, augments, bone healing, and regeneration. Augustine, whenever you are ready.
Orthopedic trauma surgeons love radiographs. We assess the patient and then we spend countless hours poring over these films, analyzing the fracture characteristics, determining the optimal mode of fixation, and devising the ideal construct. The typical equation can be simplified as bone plus blood supply plus metal equals fracture healing. However, this is not always the case. Open fractures and those with associated muscle loss do not heal as often as 1/3 of the time. The problem is the radiographs in the equation do not account for the muscle that encases the bone. Surgeons have developed ingenious approaches to preserve the muscle, recognizing its importance in blood supply and function outcomes, but little further research has been done. Could muscle play a more significant role? The focus of my research has been the role of muscle in fracture healing, and the early results have been exciting. In a rat model with a bony femoral defect of critical size, meaning it won't heal on its own, you can get this to heal with local delivery of BMP2, a potent bone regenerative molecule. That same model, though, with a local muscle defect, will not heal, even with supraphysiologic dosing of BMP2. Our lab has looked at the growth factors and cytokines that muscle secretes. We term this the muscle secretome. The muscle secretome consists of numerous factors, including IGF-1, VEGF, interleukin-8, platelet-derived growth factor, and bone morphogenic proteins. All that have been shown to be key factors in bone regeneration, illustrating muscle's role as a paracrine organ for bone. Furthermore, local delivery of that muscle secretome to the same rat model will result in bone regeneration. This demonstrates muscle's direct effects on fracture healing. Even further, if you take mesenchymal stem cells and you expose it to this muscle secretome, you get a synergistic effect with those stem cells now secreting factors that further augment that bone healing avenue of potential therapeutic research. So although we can't see muscle on radiographs, we now recognize its importance in fracture care. The simplified equation is actually much more complex, but it needs to include muscle as an essential element for fracture healing. As we clinicians and scientists look to further enhance fracture healing, the therapeutic potential of the muscle-bone interface demands further investigation. Thank you for your attention.
Thank you so much. All right, does anybody have a question?
There is something in this chat, Sarah, I think.
Yes, see one now. All right, so how to ensure the quality of the muscle secretome?
I think that's a great question. I think, just looking at in vitro, the myoblast producing all these factors doesn't take into account the different muscle types and doesn't take into account the different muscle locations. And especially if you're thinking about damaged muscle or muscle that you're transplanting in terms of a free flap, those all could be very different sort of secretomes being expressed at different times in different locations. So I think going forward, what we really need to do is look at some of these in vivo models and try to either using RNA or DNA sequencing, look at what are the secretomes being produced at different locations at different times in different sort of models.
Thank you so much.